right, today we're going to be going over note card 2, which is analytical strategies for finding limits. And the three things we're going to be looking at are direct substitution, trying first to plug in, and then we're going to try to factor using cancellation technique. And then number 3 is one thing you're going to have to remember. It's a special trig limit. And it's this one right here. The limit as x approaches infinity of sine x over x equals 1, and different ratios of that. So that last thing is something you have to remember. The first two are techniques. So what we're doing is we're building upon last class period we had 2 days ago. What was it we did?
Like graphic?
We did, yes, okay. We did graphical limits, right? We looked at graphs and approach from the left and from the right. Gavin, have you been watching our videos, I hope?
Definitely.
Okay, Gavin should have been if he wasn't, okay?
Right.
Because I've sent them out, all right?
Should have.
But
My knuckle itches.
let's go to, we're going to go into the examples. There it is. Now, we're going to cycle through and do 1 and 2, but we're going to look at number 2 first here. The first thing we're going to do is that strategy number 1, which is try direct substitution. So I'm just going to write here. Let me get a smaller pen. Okay, so we'll say limit as x approaches 1 of, we'll just put in 1 squared plus 5 times 1 minus 6 over 1 minus 1. And what is that going to end up being?
Something over 0.
One plus 5 minus 6 is
0.
0, right? And 1 minus 1 is
0.
0. Okay, what this is, this 0 over 0 is a very common thing you'll run into. It's called the indeterminate form. And indeterminate form means you do not have an answer, because we can't get an answer either way. It would be, if you had something over 0, the thing would be undefined, right? And what would it be if you had 0 over something?
0.
0. So 0 over something would be an answer. Also, something over 0 would be an answer. But when you end up with 0 over 0, that's your indeterminate form. And in the context of the way we look at things in this class is whenever you have a 0 over 0, what that means is this. It means this is for you more work.
Oh, I thought it was like we were done.
No, so we got more work to do.
That's sneaky, Mr. G.
And so what we had is we did our cancellation tech. We already did our substitution. We've got 0 over 0.
Now we got a factor.
And so this is what, when you see these types of problems, this 0 over 0 is what you are most likely going to see. Now, not always, but most likely, because you're going to want to have problems are going to be ones you have to work out, right? And so that's what we have. So we're going to try substitution instead. And we are trying substitution. We're going to try factoring. One thing that happens, if you see something like this, what that usually means, in fact what it always means, is that this thing, for this thing to be 0 over 0, this thing in the denominator has to be a factor of what's in the numerator, because that's the only way for that to be possible. So we can instead rewrite this as limit as x approaches 1, and then we have x minus 1. And for this to be a 0 over 0, we know we have to have one of the factors being x minus 1. Is that right? So now we can ask ourselves, what times x minus 1 equals this thing up here? Well, it's going to be x
Plus 6.
plus 6, okay? Plus 6, but that's a pretty easy way to do it. And then, so now what happens?
Those cancel out.
Right. So what we have is limit as x approaches 1 of x plus 6. So what is our answer to this limit? So now we can try direct substitution again. And what do we have as our answer here?
7.
7? Does that look right? Yeah, that's going to be right. Now, last year, if you saw this thing as a function, like if we wrote this as f of x equals x squared plus 5x minus 6 over x minus 1, would there be a discontinuity of this function where x equals 1?
Yes.
There would be. Do you remember from last year what kind of discontinuity we called this? I had a t-shirt for that too. Now, this is a long time ago. If you don't remember exactly what it is, I understand. There are three different names we had for this type of discontinuity.
Oh.
I have no idea.
I don't think it's like a jump one.
No, it's not a jump, but that's a good
Point.
connection.
But there's a joint.
It is a point discontinuity.
A point.
Thank you. A point discontinuity. And so that's one of the things. And also we called it a hole. And there's one last thing we called it, which you probably don't remember, but it's called a removable discontinuity. So those three are synonymous: removable discontinuity, hole, and point discontinuity. I am glad you remembered at least one of those. That's good. Shows two things. You probably had a good pre-calculus teacher last year, and you probably were paying attention to them too.
After
I
that.
felt like crying.
All right.
Good job.
And the rest of you, is there some remembrance of that in your
Oh, for sure.
mathematics past? Hannah, you have a remembrance of that someplace, somewhere?
Yes.
Okay, very good. All right, good job, class. That was really good.
You're welcome.
Okay, let's go to this next one here. Now this one here is one. It says already if a is not equal to 0, but you can see if we plugged in 0, if we had x equals a,
You get
You
this goofy 0 over 0.
you would get 0 over 0. So I want you to tinker around with this one here and see if you can come, and so you factor if that doesn't work. So I want you to see if you can factor this one out and figure out what that is. By the way, this double asterisk here, that's indicative of an actual AP test problem.
Oh, thank goodness.
Yeah. And this one here, I don't think this is the easiest one in the world. It's essentially a factoring problem. So what you do is you take your denominator there and factor it out until you can cancel, and then you substitute in and you'll have your answer. So take a couple minutes working on that. Do we have these right hands working away on that, I hope?
Well,
What kind of factoring technique would you use on that denominator there? That's one thing, I haven't given you the review on the factoring techniques yet.
No.
Okay, I'll tell you, it's a difference of squares. That is a difference of squares.
Oh. That means, differences.
Idea of what to do there, guys? No?
Yeah, I have an idea.
Okay. So this is one of those that in the denominator, do you see that as a difference of squares? Let's rewrite this one. So we have limit as x approaches a of x minus a, and what would be this denominator written as a difference of squares? Go like this. How do you write a difference of squares?
Which is,
I don't remember.
Okay, let's talk about this.
Oh, it's something, it'd be like x plus a and then x minus a, right?
Yeah.
And
So what you have to do is take the square root of this x to the fourth power, which is
x squared.
x squared. And then you have x squared plus square root of that, a squared. Then you have x squared minus a squared. Okay, and then,
I was thinking
Are we-
something like that in my head, but I thought it was wrong.
yeah, and that's one thing that you guys are a little, and I have some review, like I gave you that review part 1, where there's review part 2, review part 3. I'm gonna hand out review part 2 today. You can start working on it today. But eventually, all these reviews are going to help tie all these back things that we've been doing or need to do fresher in your remembrance, okay? So now, we still have 0 over 0, but can we further factor this out? Okay, we have x squared plus a squared unfactorable. What about this?
I'm still trying to write that down. Ah, it's another difference of squares.
Uh-huh.
So it'd be x plus a and x minus a.
X plus a, x minus a. So now what happens here?
Those guys cancel.
These guys cancel. So now what we have here is we can just plug in at this point, right? Of 1 over x squared plus a squared x plus a. So now we're not indeterminate anymore because we have 1 in the numerator. So now we can just substitute in. So we substitute in, what do we get?
What do we substitute?
You put in a, you put in x, or you let x equal a.
My brain is not.
2, would it be like, since it'd be a squared plus a squared, would that just be 2a squared?
Yeah, 2a squared
And then 2a?
times 2a.
Or times 2a?
And so that's going to be equal to 1 over 4a cubed. So that would be it. See how this came out here? Yeah, I think it came out. Okay, so that's it. That would be our answer to that one.
That wasn't that bad.
No, but see the factoring, and that's why the review has to go to factoring, because I mean, this one here, I mean, once you look at it and think about it, yeah, that's not really that hard. But if you don't remember what to do, or that you can do this and to do it, this is one of those things that, like my dad told me, that the math is kind of easy if you get it. I know it sounds like an obvious statement. It's kind of funny, isn't it? But if you think about it, it's true, because most of the things we do in this class, and you can think back to last year, it's like they look hard to do, some of them, until you figure it out. And once you figure it out, it's like, wow, this is easy. Yeah. Okay, yeah, I know each one of us here is at a kind of a different level of proficiency in different areas, but it's the same thing. I mean, when I look at different things, it's the same thing. Okay, let's go find the limit as x approaches -4 of r of x if r of x equals this thing right here. Now, one thing you're being introduced to today is this thing right here. And we didn't talk about it much in pre-calculus last year, so I'm not going to hold you accountable for that. But what do we call this kind of a function here? I think I did mention it briefly last year. What do we call this kind of a function? It's set up in this format where you'll see f of x equals, and you'll have some bracket, and then you'll have levels. In this case, you have two of them.
I've seen it before.
Yeah, so you might have seen it. I think. Okay, let me tell you what this is called. This is called a piecewise function.
I remember you saying the words piecewise.
Yeah, we talked about it briefly last year. Okay. Now, a piecewise function is a function, but has different function rules for different parts or intervals of its domain. In this case, it has a rule of 2x squared minus 3 for x not being equal to -4, and has another rule of r of x equals 1.7 when x does equal -4.
So the only time it's 1.7 is when x is -4.
Well, so Aaron asked the question, the only time x is that r of x is 1.7 is when x equals -4. Okay, we know it is that, but
Oh, I guess it still could be.
it could be here also,
Okay.
right? And so what you have to do is you have to do some analysis and figure out now, which one decides what the limit is of the function? The one on top or the one on bottom?
The one on top.
Why, okay, Aaron says the one on top, he's right. Why is Aaron right about that?
He's always right.
Well, he's often right, but he's not always right, if you think about it.
Stupid.
No, why is the top one the consideration for limits? Pardon me?
Because it has an X.
Okay, that's not, look at graphically, right? When we did the graphical last class period, what do you have to have a limit? You need two things.
Gap.
The big O, I don't know, that's the, you need to,
Okay, here, let me show you what you need. You need to find out the limit as x approaches, in this case,
on the left.
-4, yep, exactly, from the left of r of x equal to the limit as x approaches negative 4 from the right of r of x.
If it's just like a, then it doesn't.
And so in the case of 1.7, you don't have a left side and a right side, because you just have a point defined. And so it's going to have to be this consideration here. So let's go ahead and find that limit as x approaches negative 4 from the left side. How do we find that out? Well, we'll plug in negative 4 for x, right?
Yeah.
And we know that's going to be the same as the right side limit. So is there going to be a limit here? Yes, there is, because the left side and right side limit are the same. So what do we have here for that?
I'm still trying to write stuff down. Oh, man.
This, to me, now I know I have more experience, but this is like a 5 or 10 seconds in the head calculation, I would hope.
Well, I'm still trying to write it down. It's,
29, maybe?
29? Yeah, 29.
Alright,
Yeah.
yeah.
and slow.
I was writing it down.
So 29 equals 29. So what is our answer for this?
29.
29. Okay. And then the function has a different rule here. So it's like you have a graph of the function, and let's see, it's a square. So it's a quadratic function. So actually, so the function goes like this, and negative 4 looks like this, right? And then way down here someplace is 1.7. But there's a hole where x equals negative 4. Anyway. All right. What else? Finding limits algebraically classwork. And so it gives you some examples of doing this. And it says example 1, find the limit as x approaches, so that looks like negative 2, right?
Yeah.
So limit as x approaches, or is equal to, I'm just going to write down what it is, equals negative 2 squared minus 4 times negative 2 plus 1. So what's that going to be? 4 plus 8 plus 1. What is that going to be?
Okay.
13.
13? Yeah, I think it is 13, okay?
It is.
That's right. Now, then we're left with this one here, example 2, find the limit as x approaches 2 of 2x minus 6 over x minus 2. So that's going to be equal to 2 times 2 minus 6 over 2 minus 2. What is that going to be?
Would it be negative 2?
I think it's negative 2.
Or negative
Set it.
2 minus, there we go. Yeah, that's it. So what is that going to be? So we have 4 minus 6
Negative 2, negative 4.
over negative 4. So that's going to be 1/2, right? So we have a limit of 1/2 in this case. Okay, does that make sense? Okay. But now we get into the ones that you're more likely to discover, and they would be like example 3 and 4. So I want you to try your hand at those. Try try to find the limit for these, for 3 and 4. Can you do that? Yes, you can. This phone doesn't work. This van. Hello? Hello, Miss Van. Hello? Hello? Okay, you got 0, 0, so what did you get for this one here?
X plus 2.
So x plus 2, like that?
X plus 2 times x minus 4, right?
Yeah, that's right.
What's this one here?
And that's the difference of squares.
X minus,
X plus 2 and x minus
6.
So that goes away here, right? So now if we plug in, is that a -2 there?
Yeah.
Yeah.
Okay, so it was -2 minus 4. Does that look right?
Yes.
Okay. Now this one here is, you have a cubic right here. So this is going to be hard to cancel in the denominator, but let's go look at it pretty quickly anyway. What'd you get for your factoring on top?
X minus 1 and x minus 1.
X minus 1, x minus 1.
Yes.
Okay, and down here, you know you have 0 over 0, so you know one of these factors is going to be x minus 1. How do you find out the rest of this thing here? Let's go work that out here, figure out what it is.
Synthetic division.
So 1, and then we'll put 1, 0, 0, -1 here, right? So we got 1x squared, boop, boop, boop. 1, that's 1, right? Plus x, and then what's this? 1, and then 1 times 1 is 1. 0. So we're going to have x squared plus x plus 1. And we've canceled this one out. Hello? Hello? I need to pick this up here. 1, 2. Hello? Hello? This man, she's trying to call me. So anyway, now can we plug in we're gonna get 0 over 3, right? So that's gonna be 0. Right, if you plug in 1, you'll get 0 over 3. So 0. We're gonna go work on this more next time. I'm gonna hand out the sheet, review sheet number 2.